Ever wondered what it'd be like to have a duplicate of yourself? Like a digital sidekick who's exactly you? You'd totally nail decisions, like knowing squats might tweak your knees, because your twins got the scoop. Sure, you're not quite living in a sci-fi movie with full-on avatars yet, but digital twins are already out there, rocking the real world in amazing ways by simulating everything from workouts to machines. In this video, you will explore the foundation of digital twin technology through a familiar tool, your health tracker, like a Fitbit. You'll discover what a digital twin truly is, how it operates, and the core principles that define it. You'll trace the origins of this groundbreaking concept back to its roots in the 1960s, uncovering how it evolved into the tech-shaping industries today. You will dive into the distinct types of digital twins, what they are, how they differ, and the unique roles each one plays. You will compare how digital twin software works across both small-scale applications and massive systems. Finally, you'll demystify the key differences between traditional simulations and modern digital twins, because yes, they're not the same thing. Let's zoom into the foundation of digital twins, starting with something familiar, like Fitbits or Apple Watches, worn by thousands. These tiny powerhouses scoop up everything: your activity, your sleep, your whole vibe. Inside, they're loaded with slick math and science models. Some are data-trained to catch whether you're walking or crashed out, while others use physics to track your heartbeats or sleep vibes. Blend that data with the models, and boom, data assimilation kicks in. It's like your custom digital twin taking shape, constantly updating as your body spills more data. And the payoff? You unlock recommendations and tips that are all just about you. It sounds so cool. So, what's a digital twin? Picture a virtual version of something real, like a digital mirror that's loaded with data and tracks the physical parameters live. It's your go-to for simulation, integration, testing, monitoring, controlling, maintenance, and analysis. How's it made? You grab every detail about whatever you're copying, every part, how they click together, even the space they're in, and rebuild it digitally. Cool, right? Digital twin works in 3 key stages: see, think, and do, which you will understand each one. First, you take your real-world object or process and load it up with sensors and IoT devices. These gadgets are like spies, keeping tabs on all the vital stuff. They're constantly grabbing data about how the object's performing in the real world. Then, the collected data will mix with models, usually based on physics, to build something special, a digital twin. This isn't just any virtual copy, it's a personalized, one-of-a-kind model tailored to your specific object. And here's the kicker: it's not static. The digital twin keeps evolving thanks to a steady flow of fresh sensor data, plus user feedback, new inputs, and even historical data to make it sharper. That's the C stage. Now that you've got your digital twin, it's time to put it to work in the think stage. The twin taps into some seriously cool tech. Think artificial intelligence, AI, machine learning ML, simulations, data science, and control systems. With all this brain power, it can play out what-if scenarios such as what if you tweak the design, what if time passes or conditions change. The best part? You can test all these ideas without ever touching the real-world object. It's like a sandbox where your digital twin experiments with changes, showing you the effects on performance or safety, while the actual asset stays safe and sound. Finally, in the do stage, all those brilliant insights are taken from the simulations and brought back to reality. The digital twin doesn't just dream up ideas. It proposes actionable options. Whatever it is, the real thing gets better. Now, you can break the digital twin concept, which is built on 3 parts. First up is the physical object or process, simply doing its thing in the real world. Next is the digital twin, which is like a virtual clone, tracking every move. The last part is the digital thread, this excellent link that keeps them talking, passing data back and forth like a live stream. It's the ultimate tag team between the physical and virtual worlds. It turns out that the digital twin was kicked off in the 1960s with NASA. They were using a mirroring tech to make copies of their space systems. The big test came with Apollo 13, when oxygen tanks failed, leaving the spacecraft stranded. NASA didn't freak out, though. They had a replica on Earth. They grabbed data from the actual spacecraft, fed it into their ground simulator, and tweaked it to match the damaged ship. From there, they ran all sorts of what-if scenarios and played around with predictions to pick the winning moves and bring the astronauts back home safe and sound. Total game changer. Digital twins aren't one-size-fits-all, they've got layers. Where they shine depends on what you're focusing on. Here's the lineup. First, the part twin. A digital snapshot of one little component, like a servo motor or a sensor, that's critical to the whole deal. Next up is asset twin. When parts buddy up to make an asset, this twin tracks how they play together, spitting out performance data you can turn into gold star fixes. Next, you hit system twin, zooming out to show how assets link up into a full-on system, total visibility on how it all connects. Fourth is the process twin. This one's macro, showing how systems sync to run a whole production gig, nailing down timing for maximum efficiency. And finally, the enterprise twin, a mega network of twins tied together with IoT to make the entire operation slicker and smarter. Do you know where the digital twin software hangs out? The answer is for small and straightforward processes. The software is right on your desktop PC. The twin sends its zeros and ones straight to your computer with no detours, super easy. But for the big and complex stuff, like a whole factory setup, the software jumps to the cloud. Here's the deal. The twin fires off its data to reach edge controllers first, those little helpers near the action, and then the edge controllers relay data to the cloud for heavy-duty crunching. It's all about scale, desktop for the small fries, cloud for the beasts. Time to settle the score, digital twin versus simulation, both virtual but oh so different. Simulations like to keep it tight, zooming in on one process at a time, like a solo act. Digital twins go big, spinning up multiple simulations to explore a bunch of processes all at once. Data is where it gets spicy. Simulations lean on old-school static inputs or whatever you toss in, staying chill without live updates. Digital twins grab real-time goodies from sensors, keeping everything fresh and lively. Info flow is a one-way trip with simulations, no chit-chat back to the source. Digital twins, though, are chatty, swapping data with the object both ways for a real team vibe. Computing power? Simulations stick to a simple stage, modeling one thing at a time, while digital twins dance in a fancy virtual playground with muscles for more significant, bolder analysis. And for boosting stuff, simulations offer a small window to tweak, but digital twins throw open the doors, giving you tons of angles to amp up products and processes. So, simulations are cool, but digital twins are next level. Alright, the last thing, got a wild digital twin tale up your sleeve? Maybe you've tangled with one and lived to tell about it? Spill the beans in the comments, we're dying to know. And hey, if this breakdown of digital twin clicked for you, let's make some noise. Slam that like button, blast it to your friends, stash it in your playlist, and hit subscribe to join the squad. It's your way of shouting, keep it coming, and trust me, it fires us up to drop more awesome content your way. Let's keep the good vibes going.